By March 1945, Japan's aircraft industry was dying. American B-29 superfortresses had spent months systematically destroying factories, refineries, and production facilities across the home islands. The firebombing campaign that consumed Tokyo on March 9 to 10 killed over 100,000 civilians and obliterated 16 square miles of the city, including critical manufacturing districts. But the industrial devastation went deeper than burnt buildings. Japan's access to aluminum had evaporated. Bauxite shipments from the East Indies, once reliable, had been severed by American submarines that turned the South China Sea into a graveyard for Japanese merchant vessels. By early 1945, submarine warfare had reduced Japan's merchant fleet by 90%. The aluminum that remained was being hoarded for existing aircraft programs, and even those were producing planes at a fraction of pre-war rates. Engineers at Nakajima Aircraft Company faced an impossible mandate from the Imperial Japanese Army Air Service. Japan needed fighters, thousands of them, to defend against the anticipated American invasion. Intelligence suggested Operation Downfall would begin in late 1945, bringing millions of Allied troops to Japanese shores. The Kamikaze strategy, despite its horrific human cost, had proven tactically effective at Okinawa, where suicide attacks sank dozens of American ships and killed nearly 5,000 sailors. But kamikaze missions required aircraft, and Japan simply couldn't build conventional fighters fast enough with the materials available. The aluminum shortage wasn't just severe, it was catastrophic. Production of the vaunted Mitsubishi A6M0, once the symbol of Japanese air power, had slowed to a trickle. The solution proposed by Nakajima's design team sounded insane. Build fighters from wood, not balsa or lightweight construction timber, but actual structural wood that could withstand combat stresses and high-speed flight. The concept wasn't entirely unprecedented. The British had successfully deployed the de Havilland Mosquito, a wooden bomber that performed brilliantly throughout the war. But the Mosquito was a precision-engineered masterpiece, requiring specialized adhesives, carefully selected woods, and skilled craftsmen. Japan in 1945 had none of these luxuries. What they did have was forests. Japan's mountainous terrain was covered in timber, pine, cypress, birch, materials that required no imports, no complex supply chains, no aluminum smelters running on electricity the country could barely generate. The project received official designation in March 1945, the Nakajima Ki-115 Tsurugi, meaning saber. The name carried symbolic weight. The Tsurugi was a straight-bladed sword from Japanese antiquity, simpler than the curved katana, but equally deadly. The metaphor was intentional. This aircraft would be stripped of everything non-essential, a flying weapon designed for a single mission. The engineering team, led by Yasumi Fuwa, had 6 months to move from blueprints to operational deployment. Their brief was brutally clear. Create a fighter that could be mass-produced by unskilled labor, flown by minimally trained pilots, and used once. Manufacturing time per aircraft couldn't exceed 500 man-hours. Cost per unit had to remain below 30,000 yen, roughly half the price of a conventional fighter, and it had to work. What emerged from Nakajima's Ota factory in the following weeks would challenge every assumption about aircraft construction. The Ki-115 would incorporate wood in ways no combat aircraft had before, rely on simplified systems that veteran pilots would consider suicidal, and prove capable of performance that defied its crude construction. But the question hanging over the entire program was whether Japan could produce these aircraft in meaningful numbers before the war ended, and whether they could actually destroy American bombers once deployed. The first Ki-115 prototype rolled out of Nakajima's Ota factory on June 25, 1945. It looked nothing like the sleek fighters that had dominated early war Pacific skies. The fuselage sat low and squat, with a brutish, utilitarian profile that suggested farm equipment more than aerial warfare. Most shocking to observers was the landing gear, 2 fixed wheels jutting from the fuselage, completely exposed to airflow, with no mechanism to retract them. This wasn't a design oversight. It was intentional. Retractable landing gear required hydraulic systems, mechanical complexity, and precious aluminum for the wheel wells. The Ki-115 needed none of that because it was never designed to land more than once. The operational concept was devastatingly simple. A Ki-115 would take off from a prepared airstrip, climb to intercept altitude, locate its target, typically a B-29 formation, and crash into it at maximum speed. The pilot needed to land the aircraft exactly once, during training. After that, the landing gear was disposable. Some prototypes featured detachable gear designed to fall away after takeoff, reducing drag and increasing speed. Other versions kept the fixed gear throughout the mission, accepting the aerodynamic penalty in exchange for mechanical simplicity. Either way, the gear served its purpose, and nothing more. The cockpit instrumentation reflected the same ruthless minimalism. Conventional fighters of the era featured dozens of gauges monitoring engine temperature, oil pressure, fuel mixture, manifold pressure, and countless other variables. The Ki-115 had 7 instruments: airspeed indicator, altimeter, compass, engine tachometer, fuel gauge, oil pressure gauge, and a simple slip indicator. No radio equipment. Communication was unnecessary for a one-way mission. No oxygen system. The aircraft would operate below 15,000 feet where pilots could breathe naturally. No gun sight beyond a simple fixed ring mounted on the cowling. The windscreen was flat plate glass instead of curved plexiglass, eliminating the need for specialized molding equipment. Engine selection posed a critical challenge. Japan's most powerful radial engines were allocated to conventional fighters and bombers. The Ki-115 received the Nakajima Aircraft, a 14-cylinder radial producing 1,050 horsepower, adequate but not exceptional. This engine had been in production since 1942 and was well understood by maintenance crews. More importantly, it could run on lower-grade fuel than high-performance engines, a crucial consideration given Japan's fuel crisis. By mid-1945, Japanese refineries were producing aviation gasoline with octane ratings as low as 87, compared to the 100-octane fuel American fighters used. The He-35 could tolerate this poor-quality fuel without catastrophic engine failure, though performance suffered. The armament configuration was equally stripped down. Early designs proposed mounting two 20mm cannons, but tests revealed the wooden structure couldn't handle the recoil stress without reinforcement that would add weight and complexity. The final configuration carried a single 20mm Ho-5 cannon in the nose with 100 rounds of ammunition, supplemented by two 12.7mm machine guns with 250 rounds each. For a kamikaze mission, even this was arguably excessive. The aircraft itself was the primary weapon. But Japanese planners recognized that some Ki-115s might be used for conventional interception if the situation demanded, so minimal offensive capability was retained. Perhaps most revealing was the fuel capacity. Just 200 litres, enough for roughly 90 minutes of flight at cruising speed. A standard Zero carried 525 litres. The Ki-115's limited range reflected its intended role: short-distance interception of bomber formations approaching Japanese cities. Pilots would take off, climb rapidly to intercept altitude, engage the enemy, and either destroy their target through collision or exhaust their fuel trying. There was no provision for extended patrol, no consideration for combat maneuvering that might burn extra fuel, no safety margin for adverse weather. The aircraft carried exactly enough fuel to complete its mission, and nothing more. The structural engineering behind the Ki-115 represented a masterclass in desperate innovation. Traditional aircraft construction in 1945 relied on aluminum alloy frameworks, ribs, spars, and stringers, forming an internal skeleton covered with stressed metal skin. The Ki-115 abandoned this entirely. Instead, engineers turned to laminated wood construction, a technique that bonded thin layers of wood, together with adhesive to create structural members stronger than solid timber. The process wasn't new. Furniture makers had used lamination for centuries, but applying it to a combat aircraft operating at 300 miles per hour required solving problems no carpenter had ever faced. The primary structural material was Japanese red pine, selected for its availability and reasonable strength-to-weight ratio. Pine grows abundantly across Japan's mountain ranges and required no importation, but pine alone was too weak for high-stress components like wing spars and fuselage longerons. The solution involved cross-laminating, stacking thin pine veneers with grain oriented in alternating directions, then bonding them under pressure with phenolic resin adhesive. This created composite beams that resisted warping, splitting, and the directional weaknesses inherent in solid wood. The wing spars, critical load-bearing members that transferred lift forces from the wings to the fuselage, consisted of 7 layers of 3mm pine veneer laminated into I-beam sections 15 centimeters tall. The adhesive technology was crucial and problematic. High-quality aircraft adhesives like those used in the British Mosquito required casein or urea formaldehyde resins that could cure at moderate temperatures and maintain bond strength across wide temperature ranges. Japan's chemical industry in 1945 couldn't reliably supply these materials. Instead, Nakajima engineers used phenolic resins, essentially a primitive form of bakelite, that were available from domestic producers. Phenolic adhesives were strong and water-resistant, but required high curing temperatures around 140 degrees Celsius and significant pressure during the bonding process. Factories had to construct heated presses specifically for laminating aircraft components, adding complexity to what was supposed to be a simplified manufacturing process. The fuselage construction used a monocoque design, a technique where the outer skin carries primary structural loads rather than relying solely on an internal frame. Workers built up the fuselage by laying wooden strips diagonally across molds, creating a spiral pattern that distributed stress evenly. Each layer was glued to the previous one, building thickness gradually until the fuselage shell reached sufficient strength. This method required no complex metal forming equipment, no welding, and minimal skilled labor. Essentially, workers were building a large wooden tube using the same principles a basket weaver might employ, just with precision tolerances and aviation-grade adhesives. The completed fuselage weighed just 180 kilograms, remarkably light for a structure that had to contain an engine producing over 1,000 horsepower. Wings presented the greatest engineering challenge. Aircraft wings must flex under load. Rigid wings snap under the stress of high G maneuvers, but they can't flex too much, or they'll shed airflow and stall. The Ki-115's wings used a composite structure. Laminated pine spars for primary strength, plywood ribs to maintain airfoil shape, and fabric covering stretched over the framework. The fabric was ordinary cotton cloth, treated with cellulose acetate dope, a lacquer that shrank when it dried, pulling taut across the wing surface. Multiple coats of dope created a reasonably smooth aerodynamic surface, though it was nowhere near as refined as aluminum skin. Weight savings were substantial. Each wing weighed only 85 kilograms complete, compared to 140 kilograms for an equivalent metal wing. Metal components were limited to absolutely essential items. The engine mount was steel tubing, no way around that, as wood couldn't withstand engine vibration and torque loads. Control cables were steel wire. The landing gear struts were steel. Fasteners were steel or brass. But engineers minimized metal use everywhere possible. Even the control surfaces, ailerons, elevator, and rudder, used wooden frameworks covered with fabric. The entire aircraft contained less than 150 kilograms of metal, compared to over 800 kilograms in a conventional fighter. This meant Japan could theoretically build 5 Ki-115s with the aluminum required for 1-0. The first test flight occurred on July 3, 1945, at Nakajima's Ojima airfield. Chief Test Pilot Lieutenant Shigeo Fuji strapped into the cramped cockpit with considerable skepticism. He had flown Zeros, the elegant Hayate fighter, and nearly every aircraft Nakajima had produced. The Ki-115 felt fundamentally different, cruder, more agricultural. The wooden control stick flexed noticeably when he moved it through its range. The throttle quadrant was stamped metal instead of machined aluminum. The seat was barely padded plywood. Everything about the aircraft screamed temporary and disposable. Fuji's pre-flight inspection notes included the phrase, "Construction quality resembles urgent carpentry project rather than precision aircraft." Takeoff revealed the first surprise. Despite the fixed landing gear creating significant drag, the Ki-115 accelerated quickly. The Hay-35 engine bellowed at full power, spinning the three-blade propeller at 2,400 RPM and pulling the aircraft to flying speed within 350 meters. Rotation was abrupt. The tail came up suddenly as airspeed built, and the aircraft lifted off with minimal pilot input. Fuji later reported that the takeoff characteristics were enthusiastic, almost eager, though he noted the controls felt mushy at low speeds, a predictable consequence of the fabric-covered surfaces and flexible wooden framework. Climb performance exceeded predictions. The Ki-115 reached 3,000 meters in just under 6 minutes. Not spectacular compared to dedicated interceptors like the J-2M Raiden, but entirely adequate for its intended mission. More importantly, the rate of climb remained consistent across the altitude range, suggesting the engine was delivering power efficiently, despite the aerodynamic compromises. The fixed landing gear cost approximately 40 kilometers per hour in maximum speed, but engineers had anticipated this penalty. At 5,000 meters, Fuji recorded a maximum speed of 550 kilometers per hour, faster than early war Zeros, and sufficient to intercept B-29s that typically cruised at 350 kilometers per hour. Maneuverability testing produced the day's most unexpected results. Conventional wisdom suggested a wooden aircraft would be sluggish and unresponsive, unable to match the crisp handling of metal fighters. The Ki-115 proved otherwise. The lighter weight and simplified control systems created surprisingly nimble handling characteristics. Roll rate was excellent. Fuji could bank the aircraft from 60 degrees left to 60 degrees right in just under 2 seconds. The fabric-covered control surfaces responded immediately to stick inputs without the mushy lag common in heavier aircraft. In simulated combat maneuvers against an imaginary opponent, Fuji found he could execute tight turns without excessive altitude loss and reverse direction rapidly. The wooden structure did impose limits. Sustained high G maneuvers caused concerning creaking sounds from the fuselage, and Fuji noted visible flexing in the wing roots during hard turns. Engineers had calculated a maximum load limit of 6 Gs, adequate for interception work, but modest compared to purpose-built fighters rated for 8 or 9 Gs. Diving speed was restricted to 650 kilometers per hour, beyond which the fabric covering began to flutter ominously. These weren't crippling limitations for kamikaze missions, where the pilot would make one aggressive intercept and either succeed or die trying, but they would prevent the Ki-115 from engaging in prolonged dogfights with American escorts. Stability characteristics were neutral to slightly positive. The aircraft flew hands-off without significant tendency to roll or yaw. though it lacked the rock-solid stability of larger bombers. Stall behavior was gentle. The nose dropped predictably when airspeed decayed too far, and recovery required only relaxing back pressure and adding power. Fuji deliberately stalled the aircraft 6 times during the test flight, approaching from different configurations. Each time, the Ki-115 gave adequate warning through buffeting and maintained controllability throughout the stall. For pilots with minimal training, this forgiving behavior could mean the difference between recovering from a mistake and spinning into the ground. Landing presented the true test of the disposable concept. Fuji brought the Ki-115 around for approach, reduced power, and descended toward the runway. The fixed landing gear simplified the procedure. No gear extension to forget, no hydraulic failures to worry about. Touchdown was firm but controlled. The gear struts compressed, absorbed the impact energy, and the aircraft rolled to a stop within 400 meters. Post-flight inspection revealed no structural damage, no separation of laminated joints, no fabric tears. The wooden fighter had survived its first flight completely intact, defying the expectations of nearly everyone who'd watched it take off. The combat debut of the Ki-115 remains one of World War II's most poorly documented episodes, buried under layers of incomplete records, conflicting accounts, and deliberate post-war obscurity. What can be established with reasonable certainty is that between late July and early August 1945, a small number of Tsurugi aircraft were deployed to forward airfields in the Kanto region surrounding Tokyo. The exact number varies by source. Some accounts suggest as few as 8 operational aircraft, others claim up to 25 reached combat-ready status. The 47th Shimbu Squadron, a special attack unit based at Narimasu Airfield in Saitama Prefecture, received the first operational Ki-115s in the final week of July 1945. American bombing records from this period show unusual encounters that align with Ki-115 deployment. On August 1, 1945, a formation of B-29s from the 73rd Bombardment Wing approached the Kawasaki industrial area in broad daylight, part of the relentless campaign to destroy whatever manufacturing capacity Japan retained. The bomber stream consisted of 47 aircraft flying at 22,000 feet, escorted by P-51 Mustangs flying top cover at 25,000 feet. At approximately 1340 hours, radar operators aboard the lead bombers detected aircraft climbing rapidly from below. Unusual because most Japanese interceptors by this stage of the war struggled to reach B-29 altitude quickly enough to mount effective attacks. What happened next appears in the mission reports of the 497th Bombardment Group. Multiple crews reported fighters attacking from below and behind, climbing at steep angles and closing rapidly, despite the B-29's defensive fire. These weren't the familiar profiles of Zeros or Tojos. Crews described aircraft with fixed landing gear, straight wings, and aggressive attack patterns that suggested either exceptional pilot skill or suicidal intent. Tail gunners on at least 3 bombers engaged targets closing within 800 meters before breaking off or passing through the formation. The attacks lasted approximately 12 minutes before the interceptors disappeared, either diving away or exhausting ammunition. The damage assessment from that single mission documents 4 B-29s with significant battle damage requiring emergency landings at Iwo Jima, 2 aircraft that ditched in the Pacific after losing engines to fighter attack, and 1 bomber, City of Los Angeles from the 869th Squadron, that exploded catastrophically at 22,300 feet after what survivors described as a kamikaze collision. Surviving crew members rescued from the ditched aircraft reported seeing one attacker collide with a bomber in their formation, resulting in both aircraft breaking apart. They specifically mentioned the attacker appeared to have wooden construction visible through damaged sections of the fuselage, though this detail wasn't emphasized in official reports. Corroborating evidence comes from Japanese sources, though it's fragmentary and often contradictory. Post-war interrogations of 47th Shimbu Squadron personnel conducted by Allied intelligence officers mention special attack missions flown in wooden aircraft during the first week of August. One pilot, Warrant Officer Takeo Nakamura, survived the war, and in a 1978 interview claimed he flew 2 Ki-115 interception missions against B-29 formations, describing the aircraft as crude but effective if you got close enough. Nakamura stated he damaged 1 bomber on his second mission before being forced to break off due to engine problems, landing back at Narimasu with his aircraft barely controllable. Another documented encounter occurred on August 5th, when B-29s targeting the Nissan Motor Company plant at Yokohama faced aggressive interception. The 314th Bombardment Wing's mission report notes approximately 15 to 20 enemy aircraft, type unknown, mounting determined attacks from multiple vectors. Gun camera footage from tail gunners aboard Borrowed Time, a B-29 from the 19th Bombardment Group, shows an aircraft matching the Ki-115's profile closing to within 300 meters before opening fire. The footage is grainy and brief, only 8 seconds, but clearly shows fixed landing gear and what appears to be wooden construction visible through combat damage. That particular bomber suffered multiple 20mm cannon hits to the vertical stabilizer and lost one engine to fighter attack. The actual kill count remains unknowable with certainty. American loss records from early August 1945 document 23 B-29s lost to enemy fighter action or unknown causes over the Japanese home islands between August 1st and August 9th, when the Nagasaki bombing effectively ended strategic air operations. Not all of these losses involved Ki-115s. Conventional Japanese fighters were still operational, and accidents claimed bombers regularly. But the pattern of attacks, the descriptions from surviving crews, and the correlation with known Ki-115 deployment dates suggest at least some of these losses resulted from encounters with the wooden fighters. Production of the Ki-115 never approached the ambitious targets set by the Imperial Japanese Army. Initial plans called for 8,000 aircraft to be manufactured by December 1945, with production distributed across multiple facilities to minimize vulnerability to bombing. Nakajima's Ota plant would serve as the primary manufacturer, supplemented by smaller workshops and furniture factories converted to aircraft production. The distributed manufacturing model made perfect sense on paper. Wood construction required no specialized metalworking equipment, meaning essentially any facility with woodworking capability could theoretically contribute components. Reality proved devastatingly different. The first manufacturing bottleneck emerged immediately: quality control. Furniture makers could cut wood and apply glue, but aircraft construction demanded precision that cabinet shops had never attempted. Wing ribs needed to maintain airfoil shape within 2 millimeters of specification, or the aircraft wouldn't fly properly. Fuselage sections had to align perfectly, or control cables would bind and jam. Laminated spars required uniform adhesive application and precise curing temperatures. Too cold, and bonds failed; too hot, and wood degraded. By late July, quality inspectors were rejecting nearly 40% of components arriving from subcontractors. Parts that would have been adequate for furniture construction created dangerous weaknesses in aircraft structures. The adhesive supply problem cascaded into crisis by early August. Phenolic resin production required chemical precursors, phenol and formaldehyde, that Japan's battered chemical industry struggled to provide in sufficient quantities. Bombing had destroyed 3 major chemical plants between March and June 1945, and the remaining facilities operated at drastically reduced capacity due to fuel and raw material shortages. By the first week of August, Nakajima's Ota plant had enough components for 70 complete aircraft, but only enough adhesive to assemble 23. Engineers attempted substituting rice glue and other traditional adhesives, but these couldn't withstand the moisture and temperature extremes aircraft encountered in flight. Test samples showed catastrophic bond failure after exposure to rain and humidity. Worker skill deficits compounded manufacturing difficulties. The Ki-115 might have been simplified compared to conventional fighters, but it still required workers who understood aircraft assembly fundamentals. Japan's experienced aircraft workers were predominantly drafted into military service or had been killed in bombing raids. Replacement workers included elderly men, teenage boys, and women with no industrial experience. Training programs couldn't produce competent aircraft assemblers in the weeks available. Inspectors found control cables installed backwards, fabric covering applied with inadequate tension, and spar assemblies glued with joints misaligned. Each error required disassembly and rework, consuming time Japan didn't have. Pilot training emerged as an even more intractable problem. The Ki-115 might have been easier to fly than high-performance fighters, but it still required pilots capable of taking off, navigating to target areas, and executing attacks against defended bomber formations. By mid-1945, Japan's pilot training program had collapsed. Fuel shortages limited training flights to bare minimums. Experienced instructors were dead, killed in combat or kamikaze missions. The replacement training regimen consisted of perhaps 20 hours of flight time, much of it in obsolete trainers that handled nothing like the Ki-115. Transitioning these barely qualified pilots directly into wooden fighters for suicide missions resulted in predictable disasters. Several fatal accidents during July and early August illustrated the consequences. On July 28th, a newly assigned pilot attempting his first Ki-115 takeoff lost control during rotation, ground looped, and crashed into a revetment, killing himself and destroying the aircraft. On August 2nd, a pilot became disoriented during a test flight, flew into a mountainside in heavy weather, and was killed instantly. On August 6th, the day the atomic bomb destroyed Hiroshima, a Ki-115 suffered structural failure during a practice dive, shedding both wings at 4,000 meters and killing the pilot. Each accident removed one aircraft from an inventory that numbered in the dozens rather than thousands. Each dead pilot represented training investment Japan couldn't replace. The fuel crisis ultimately rendered the entire program nearly irrelevant. By August 1945, Japan's strategic fuel reserves were exhausted. What little aviation gasoline remained was allocated to defending against the expected invasion. Training flights stopped almost completely. Even operational sorties were restricted to situations where success seemed possible. The Ki-115s sitting at forward airfields couldn't fly without fuel, and fuel couldn't reach the airfields because American submarines and bombers had destroyed tankers and pipelines. Some units reported having aircraft fully armed and ready, but unable to launch missions because fuel trucks never arrived. The wooden fighters sat under camouflage netting, waiting for a sortie that would never come. By August 10th, when Emperor Hirohito made his decision to accept Allied surrender terms, approximately 105 Ki-115 aircraft had been completed. Perhaps 30 reached operational squadrons. Maybe a dozen flew combat missions. The rest sat incomplete in factories, parked at airfields without fuel, or hidden in dispersal areas awaiting deployment orders that would never arrive. Japan's wooden fighter had proven it could fly and fight, but the nation's industrial and logistical collapse had rendered even this simplified, desperate weapon unusable. August 15th, 1945, arrived with Emperor Hirohito's radio address, the first time most Japanese citizens had heard their emperor's voice. His words, delivered in formal court Japanese that many listeners struggled to comprehend, announced Japan's acceptance of the Potsdam Declaration and unconditional surrender. The war was over. Across Japan, military units received orders to cease all combat operations immediately, ground their aircraft, and prepare for occupation by Allied forces. At airfields housing Ki-115 squadrons, the surrender directive created chaos and despair in equal measure. At Narimasu Airfield, approximately 17 Ki-115s sat in dispersed revetments, fully fueled and armed for missions that would never launch. Squadron Commander Major Hideaki Mori gathered his pilots and informed them the war had ended. Several pilots wept openly. Others argued for launching unauthorized attacks against the American fleet already approaching Japanese waters, a final defiant gesture that Mori firmly prohibited. The emotional devastation was profound. These men had trained for suicide missions, accepted their deaths as inevitable and honorable, and now faced the psychologically impossible task of simply continuing to live. The Ki-115s they'd prepared to fly into eternity represented wasted sacrifice, unfulfilled duty, and national humiliation. Similar scenes played out at other bases. At Chofu Airfield west of Tokyo, ground crews received orders to drain fuel from 8 Ki-115s and prepare them for Allied inspection. The crews moved slowly, reluctantly, treating the aircraft with unexpected tenderness despite their crude construction. These wooden fighters represented Japan's final technological gambit, and now they would become trophies for the victors. Some maintenance personnel reportedly sabotaged their own aircraft rather than let Americans examine them, pouring sand into engines, cutting control cables, anything to render the planes unflyable before surrender formalities concluded. The Allied occupation authorities arrived in late August with specific instructions regarding Japanese military equipment. Supreme Commander Douglas MacArthur's headquarters issued directives requiring comprehensive documentation of all Japanese weapon systems, followed by systematic destruction of war-making capability. Intelligence teams fanned out across Japan, cataloguing aircraft, examining manufacturing facilities, and interrogating engineers and pilots. The Ki-115 drew immediate attention precisely because it was unfamiliar. American technical intelligence officers had never seen these aircraft in combat or identified them in reconnaissance photographs. Their existence came as a complete surprise. At Atsugi Naval Air Station, recently occupied by American forces, intelligence officers discovered a mostly intact Ki-115 that had been flown in from a forward base days before surrender. Technical teams photographed it extensively, measured critical dimensions, and documented the wooden construction techniques. Their reports expressed genuine surprise at the aircraft's sophistication despite crude materials. One assessment noted that construction quality, while visibly inferior to American standards, demonstrates impressive ingenuity under severe material constraints. The officers were particularly interested in the laminated spar construction and the phenolic adhesives, which represented techniques American industry hadn't seriously explored for aircraft applications. But documentation was preliminary to destruction. MacArthur's directives were explicit. Japanese military aircraft were to be destroyed to prevent any resurgence of militarism. Throughout September and October 1945, Allied demolition teams systematically destroyed thousands of Japanese aircraft. Zeros, Hayats, bombers, trainers. Everything was either burned, bulldozed, or dumped into the ocean. The Ki-115s faced the same fate. Their wooden construction made them particularly easy to destroy. Gasoline poured over wings and fuselages ignited readily, reducing the aircraft to charred frameworks within minutes. At some locations, bulldozers simply pushed the wooden fighters into pits and buried them. A small number of Ki-115s avoided immediate destruction by being hidden. Some were disassembled and concealed in warehouses by Japanese personnel who hoped to preserve examples of their desperate innovation. Others were abandoned at remote airfields that Allied teams didn't immediately reach. In mountainous regions far from major cities, several aircraft reportedly remained hidden in forest clearings, covered with camouflage netting and forgotten. These hidden aircraft became legends in post-war Japan, the ghost planes that survived surrender, waiting in silent revetments for pilots who would never return. The exact number of Ki-115s that existed at war's end remains uncertain. Production records were incomplete, destroyed, or deliberately falsified to hide capabilities from occupying forces. Estimates range from 105 to possibly 140 completed aircraft, with perhaps another 50 in various stages of assembly when production ceased. Of these, perhaps 3 survived into the 1950s as museum pieces or technical reference examples. The rest vanished, burned, buried, or disassembled and absorbed back into Japan's civilian economy as scrap wood and salvaged metal components. The wooden fighters had appeared from forests and returned to forests, leaving barely a trace of their brief existence. The historical erasure of the Ki-115 began almost immediately after the war ended and continued for decades. Allied occupation authorities had strategic reasons to downplay the wooden fighter's existence. MacArthur's headquarters was crafting a narrative of American military supremacy and Japanese technological inferiority to justify occupation policies and shape post-war attitudes. Acknowledging that Japan had developed a functional wooden fighter that actually shot down American bombers complicated that narrative. Better to focus on failed superweapons like the enormous Fuji balloon bombs or the fantastical submarine aircraft carriers, projects that demonstrated Japanese desperation without suggesting competence. The official USSBS, United States Strategic Bombing Survey, conducted between 1945 and 1946, devoted thousands of pages to analyzing Japanese aircraft production, technology, and tactics. The comprehensive reports examined the Zero, the Hayate, the Shinden prototype, and dozens of other aircraft in exhaustive detail. The Ki-115 received exactly 3 paragraphs in a subsection titled Emergency and Expedient Aircraft. Those paragraphs dismissed it as a crude kamikaze aircraft of wooden construction, produced in negligible numbers with no significant operational impact. The survey included no photographs, no technical drawings, no performance data. For researchers relying on USSBS documents, which became the foundational source for post-war aviation history, the Ki-115 essentially didn't exist. Japanese silence was equally deliberate, but stemmed from different motivations. Post-war Japan wanted desperately to move beyond militarism and embrace democratic reconstruction. The kamikaze program represented everything the new Japan was trying to forget: fanaticism, wasted youth, and the suicidal desperation of a losing war. The Ki-115, explicitly designed as a kamikaze weapon, was an embarrassing reminder of that dark period. Engineers who had worked on the program rarely discussed it publicly. Nakajima Aircraft Company, restructured and renamed after the war, made no effort to preserve documentation or commemorate the wooden fighter. Corporate histories mentioned it briefly, if at all. The few American servicemen who had encountered Ki-115s in combat had no framework for understanding what they'd seen. Post-war debriefings focused on conventional threats: Zeros, flak, mechanical failures. When aircrews mentioned wooden fighters with fixed gear, intelligence officers often dismissed these reports as misidentifications of trainer aircraft or combat-damaged fighters. Without physical evidence or official documentation confirming the Ki-115's existence, individual crew accounts were filed away as anomalies. Many veterans who'd actually fought against these aircraft went to their graves never knowing the official designation or history of what had attacked them. The Cold War further buried the story. By the 1950s, American and Japanese attention had shifted to jet aircraft, nuclear weapons, and the Soviet threat. World War II aviation history became the domain of enthusiasts and hobbyists, rather than military analysts. The Ki-115 lacked the glamorous appeal of the Zero or the technological fascination of German jets. It was a wooden throwback, built by a losing nation in its final desperate months, not the sort of aircraft that inspired model kits or magazine articles. Aviation historians focusing on more famous aircraft simply skipped over it. A handful of Japanese researchers began documenting the Ki-115 in the 1970s and 1980s, interviewing surviving engineers and pilots before they died. These efforts produced articles in specialized Japanese aviation journals, but the information rarely crossed language barriers into English-language sources. Takeo Nakamura, the warrant officer who claimed to have flown combat missions in the Ki-115, gave his detailed interview to a Japanese aviation magazine in 1978, but it wasn't translated into English until 1993. By then, most World War II aviation reference books had already been written without mentioning the wooden fighter. The 3 Ki-115s that survived into the museum era met inglorious ends. One, preserved at a Japanese technical institute, was destroyed in a warehouse fire in 1953. Another became an instructional airframe at an aviation school and was eventually disassembled for parts when the school closed in 1961. The third, held in storage at a private collection, deteriorated from moisture damage and insect infestation until it was disposed of in the late 1960s. By 1970, no complete Ki-115 existed anywhere in the world. Even fragments were scarce. A few photographs, scattered documents, fading memories. Today, the Ki-115 Tsurugi occupies a footnote position in World War II aviation history. Specialist books on Japanese aircraft mention it briefly. Online forums debate its specifications and combat record, often reaching contradictory conclusions due to limited source material. No flight-worthy examples exist, no detailed restoration projects have been attempted, and no major museums display even a replica. The wooden fighter that represented Japan's final, desperate innovation has been almost completely forgotten. A ghost weapon from a ghost air force, its brief moment of combat effectiveness erased by the victor's narrative and the loser's shame. Yet for the bomber crews who faced it during those final weeks of August 1945, the Ki-115 was terrifyingly real, a wooden saber slashing through formations at 300 miles per hour, proving that even in collapse, ingenuity and desperation could still draw blood.